Hello, everyone. Nice to meet everybody. Thanks for coming today. Myself and Graham Gansel hopefully have an action-packed session today on how graph and machine learning work together with some of the capabilities that Expero has put together to stop and prevent, detect, and investigate cyber fraud. So without further ado, Graham and I will be talking a little bit per each of us. We're going to show a couple of examples. We're going to walk through in some detail. And then as Laura mentioned, there'll be some questions at the end. So kind of jumping right in, gosh, Ukraine couldn't be any more timely. And or what we've been seeing is this ratcheting up of sort of issues. It's everything from cyber intrusion to stealing data out of our cloud databases, out of our on-premise databases, bad actors internally. Ransomware has seen a huge new push, and what we'll find today in our discussions is that they're all related. We're seeing that these are just the tip of the iceberg for what some of these ransomwares look like. As they start with what looks like an email, they could be intruding or blast radiusing us, they could be in there for a while, and so on. And so again, the numbers are huge. They get bigger and bigger and bigger and bigger. And then when you connect them all together, so not just ransomware, not just insider attacks, et cetera, that's where we start to see what goes on. Is there's so much more that's actually going on here. Is not just getting paid or locking down things that you need, but this ability to stop it, detect it, and is this just one of 4 to 5 to 10 things they're trying to do? They may start with ransomware, they may go at it this way and then lock it down to go do that. But I think the command and control and some of the things that we'll see today, and then specifically in machine learning, what Graham's going to share with us is how do you get into each of these, what we're going to see in a graph database is a hop or a connection, and how do you unmask that before it actually really starts to get out of hand? When we look at some of these use cases, it's very interesting, right? They come in one way or another. We're using products today like Splunk, and then some of the other products that are out there to be on the edge to help us sense it. But there's more to it, right? They're getting in, they're connecting, they're doing accounts, they're looking normal, and then they may ultimately, by the time they've exited, they may have done a ransomware. They may have looked like they did something normal if we're a bank, and then they've created other accounts and gotten credit, laundered money, or other kinds of things. And so it's much bigger potentially. And some of the customers and the examples that we'll see today, we'll talk about sort of how this one task starts to just basically get bigger, and how much can they take from us, and what is it that we're doing? That's really ultimately what we want to try and stop. So again, in this case, the ransomware started and then it got sort of out of hand. Now, what we see over on the left is these are connected use cases. And again, it could be cyber, they could be just straight out trying to get us, right? And so we don't know, but all of the rest of those, so IoT or devices or going in and spoofing or all the way down to law enforcement, right? The problem we have is it's so incredibly difficult to stop it that we're not elevating the game, if you will, which is really what we want to talk about today, which is how do I use machine learning over on the right, the patterns? What am I seeing? What are the deep link connections? They're no longer sort of simple 1 cent on your credit card and then they balloon to $100,000. That's not what happens. So that's what we want to make sure then is how do we do things in the middle? And that's really what we're going to see today is how do we use the machine learning? How do we use graph? How do we use all of the technologies at our fingertips to do these things? But more importantly, here in the center, which is how do I use that data and put it into human, or what we've heard recently as explainable AI? How do we do that in such a way to track all of the devices and things that we now have access to without overwhelming our humans? And then we can apply it to the use cases on the left. And so again, today we're going to talk and focus a bit more on sort of the cyber and the malware focus. Now, one of the promises here are how do we start to elevate this game? Most of our customers and folks that are out there that are practitioners are using machine learning or some sort of first stab at that. And what we see is these are typically on the very low end, we see that if you just start using machine learning, gosh, you're going to get something better out of it. Now, how you use machine learning and what your firm may be doing is kind of a bit all over, right? Some customers have said, I have 20 or 30 machine learning team members that are random acts of machine learning violence. And as Graham shows us here in a minute, there's more to it than just simply running some notebooks and voila, I found it. It needs to be operationalized. It needs to be integrated. And then we start to see, well, what if I use a graph database? Well, now I get an even bigger boost, right? And then I can start to look at it in a humanistic way that is this co-learning that Graham will talk a little bit about, where humans, data practitioners, machine learning experts, and then our IT team, they all have a part to play in that visualization. And it's not just our level one team members, it could go all the way down. And that's where we start to get that, is that co-learning now starts to get us, in some cases, 60% boost in accuracy, 80% decrease in false positives. And again, your mileage may vary here, but if we do it right and we combine these elements, that's really what we want to talk about today. And so what we can see then is these are real examples from customers. What is it when we start to use these combinations of things, not just machine learning, not just a graph database, but how do I use powerful user interfaces where the co-learning teaches us how to go do that? And these are some links down there at the bottom that my friend Graham has written, some great deep sort of examples of how they work and what's going on. And again, supervised and unsupervised, combined with the graph, et cetera. And the takeaway here is that you can get there. And this is not throwing out what you already have. That's the key construct, right? This is an additional or a bolt-on. And some of these customers, it was 6 to 8 weeks to bolt onto what they already had to be able to detect it in real time, be able to find it and then link it, and more importantly, learn from that and then put it back to the front end so I can get more accurate. And that's how that loop starts to work. Now, why? Why do we want to do this now? Well, our friends in other parts of the world are seeing this now, and COVID really hasn't helped the situation. It's actually created a bit more stress on this. And, being able to do this now, the constant statement of do more with less money or less humans is constant, right? That always is doing that. So, again, now is the time. And if you're using SAP or Oracle, bolting onto it is not a problem, right? That's the other thing, is there's not a big technical debt. And yes, there's always this modernization process that's going on, but let's do it now. Let's, as the analogy goes, let's change the wheels on the Indy car while it's driving, is ultimately what we want to talk about today and highlight, which is it can be done and it is pretty straightforward. So that's why we want to do this, and more importantly, what the impacts are. We've seen the numbers, everyone kind of rolls their eyes and says, gosh, those are big numbers. So let's talk a little bit about this new thing, right? Which is, it's not new. That's the takeaway, right? Which is a graph, or what's called graph analytics. And it's not a pie chart or a line graph. It's a technology, and it's a theory, as we learn here, from the 1700s. And this was ultimately done in the bridges. How do I get my king the most optimal way across all the bridges that were there? And ultimately, that's what this is built on. So the mathematical premise is we think in a graph, we see connections like a graph. And more importantly, when we look at networks and or connected people and other kinds of things, as we'll see here in a minute, it's all a graph. Now, why is a graph so different? Well, graphs connect relationships. Graphs connect nodes and vertices on those edges, and you can see them in some cases called ball and sticks or what those are. But what it does then is it gives us a power that's unique. I don't have to use the one-to-many over on the left, where I have to store the data and query it in a 40-table outer join. And that gets slow, and it starts to burden us when we're working in a 5-millisecond world. What happens now in a graph database is it can save those links or connections, that network topology, if you will, into memory, which means that now I can start to run algorithms over the top of that in real time. And I can do that now upon a massive scale to go do that. And all of the graph vendors that are out there today, they all have different flavors and different kinds of things, but graph databases on a whole are incredibly powerful for doing this. That's why we combine them with SQL and NoSQL and time series databases and other kinds of ontologies, et cetera, is because they can give us this massive leap in both performance and capability. And Graham's going to talk a bit more about that. The next thing then is, what are these different data styles, right? So we mentioned that, right? And you can go look at Dan McCreary. He's a close friend of ours. We love Dan. He's a Imperatus out in the world as a thought leader. And really what we're saying is we're going to use each of these for what they were intended. Use the graph. Sometimes it's called a knowledge graph, et cetera, property graph, other kinds of names. But the point is all of these data stores do very different things. The ability to combine those and run machine learning as a join here is the power. You don't have to now sort of force something that was never designed to do what we want it to do in this conjunction. So that's really kind of where we're going here today. Now, let's take a fun example. What's the difference between Katy Perry and Barack Obama? And for those who've probably seen some of our webinars before, you know the answer. But Katy Perry has purple hair. No, that's not the answer. But in a graph database, what we can start to realize is those balls and sticks around the edges are indeed things like influence. They could be similarity. They could be a cluster. They could be a network neighborhood. Those are all graph analytic algorithms that you air quote get for free in a graph database. Now, Katy Perry may have lots of connections, right? But she doesn't have very deep connections. So people who follow her are not deeply linked. Barack Obama, on the other hand, is deeply connected. And what we see then is his people are highly influential. So they may be heads of state. They may be senators. They may be military persons, right? Those people have higher centrality or other kinds of things. Now, let's put this in a negative context. What's the difference between a travel agent and human trafficking? Identical types of similarities in the graph. Our travel agent has lots of people that use them, but they're not connected to each other. People that are in nefarious networks like cyber rings or other kinds of fraud by nature are not necessarily unconnected. They are typically abnormally connected, and inside of a graph database, as Graham will show us, they can both visually in a 3-dimension be able to see what the pattern is that's different, and through a series of these algorithms that we keep talking about, they are very different. And now I can actually create that accuracy that I spoke of. How do we get that accuracy? How do I reduce the false positive? This is really the indicator, or why a graph database is so incredibly powerful. Now, who are you in this stack? Are you an executive? Are you an IT person? Are you a data science? Are you a team? Are you an investigator? You could be any of those. The goal here is that everyone has a way to touch the elephant, as they most likely do today. But what Expero is bringing to the table now is this unique capability of using the graph database, bolting it onto what you already have, the current sensing mechanisms, et cetera, and then who you are. We've created modules or capabilities now that let everyone sort of be able to touch that elephant. And Graham's going to show us what it looks like in the analytics. I'm going to show a little bit of what it looks like in the investigation, customer facing, and executives. And the goal here is that that combination of that visual combined with the superpower now of what we've got here is what raises the game. So if you already have Tableau dashboards, if you already have Power BI or Looker or using Splunk or other kinds of things, these elements are designed to pop into what you have so that you can now maximize the benefit of what this is. Now, how do we do that? Well, obviously, we have our own set of toolkits and those kinds of things. The financial crimes are here to do those elements. Now, graph databases come in different sizes and colors, right? And that's really what we want to say then is this combination of these elements is really that 1-2 punch. And again, you can go look at the website. But where we're going now is our friends at Bank of America said, I need to stop fraud on day one. Why was the Expero sort of capability so incredibly fast? We have these modules that bolt into what they already had. They were using other products. They were using Tableau. They were using other kinds of systems that were there. They were using Actimize and SAS, and they use FICO, and they use all kinds of things, right? The capability now is that let's plug it in and let's go. And that's really kind of where we find these different ways, is depending on who you are, you may be just connecting the data out of cyber connections. You may be looking at Splunk. We have the ability now to connect that data, create things like trust or other kinds of functions. We have workflow capability. So what happens if I find a fraud? What happens if I have investigations? How deep does this rabbit hole go? What do I want to do? How is it all connected? And we'll see these in action here in a minute. And then we have dashboards, we have case management, alerts, and adaptive analytics that Graham's going to talk to us about. And then finally, exploration. All of these can be either combined, or in your world, right, you may want one of these, or just sort of technologically connecting this without a user interface. We can help in all of those different categories. But the point is, we're trying to use these as fast as we can. Back to that IndyCar analogy, right? Is if you need to change the tire, or you don't have a tire on some of these different elements, we can help you get there. Now, how does this all fit together, right? The core takeaway here is very simple. There is this capability to sense from all kinds of data. So again, if you have Juniper devices, or you have Databricks or Cisco, or you're using Microsoft or Google or AWS, there are products and services that are out there that can now feed into this. We can take your own data inside of your environment for your customers. And if you have MAC IDs or other kinds of device controlling items, cookies, et cetera. And then we can juxtapose that against blacklists, right? So we have that ability to bring it in. Some people call that master data management, but it's really data enrichment. It's taking it up a notch. The fact that Scott Heath may have 15 addresses over the last 2 years, and I see 22 different devices that have different MAC or IP addresses or other kinds of coding that we'll see here in a minute, that's bad. But I want to know what all those are. I don't want to just find the one connection of Scott and call it a master data. I actually want to look and interrogate, because those are perhaps things that are bad that suspiciously can connect to other things. It could turn into a network or a ring of things. And that's why we're able to juxtapose, whether open corporates or Moody's or those PEP lists, et cetera. I can start to infer now to say, I know Scott, and he's been in perhaps our bank or our website, or he's bought from us before. So I know him, but I see that there is someone that looks like him on a blacklist, Scooter Heath, or a MAC ID that may be similar, that has been associated with fraud previously. So maybe his trust is lower than his known ability. That is now sort of our first step. Then as we get into the second part, which is now how do we use machine learning and Boolean logic and graph capability to create a much more accurate score that can suss out where the real risk is, where is the real fraud, how can I shut down an account in 5 or 10 milliseconds, and then create a trail that I can train. That's ultimately what's going on in here. And my friend Graham here will tell us much more about that. And then finally, that human in the loop. How does the human see it? What does that look like? I'll give a quick demo here in a minute of what that part looks like, which then feeds back into the system and it gets smarter over time. So that's really kind of how it all fits together. And for those that have seen us before in some of these webinars, this is really sort of the crux of what we do. Now, what do those interactions with humans on the business side look like, right? They could be a level 0, right, where I need to just say there's an alert. Or in this case, I could be a level 3, where I need to see the detail. And then how does it go from something that I found in an alert all the way down to I'm seeing a file replicate on a server, and more importantly, how do I shut that down immediately before it actually gets there, right? That's that in, finding something, detecting something in a very short period of time, and then actioning it, and more importantly, protecting or safeguarding going forward so that it doesn't happen again. And as they change and morph, we need to keep up with that capability. Now, let's say I'm a level 1 or a level 0. Now, perhaps I want to see something that's simplistic, that says, do not accept this. I may have multiple systems that may be recommending to me as well. I may have one system that says, yeah, it's okay. I may have a second system that says, oh, no, it's kind of in the middle. But what we can do now is bring that up a notch. And with that higher accuracy that I mentioned, we can be much more prescriptive. We can show the vectors, and Graham's going to talk again about that. We can show this in a very explainable way to a human that says, you should reject this for the following reasons in the bottom. There's a location element. There are some features or elements that are brought to the table here. This device ID is too connected to too many other fraudulent links. Please don't do this. Now, we're giving the human a choice. And if the human says, well, no, that's okay, again, it becomes part of that learning loop that we go. We can show time. We can show time and space. And now we can see correlation. So where did things happen? In this sort of instance, right, we see that things happen in a certain place, but there are other elements that lead us to believe that's bad. This person may have been on vacation and somebody was trying to log into something that was not there. Or perhaps they were using, as we know now, they were from home when perhaps they were in our office, and there are other kinds of elements. So the system can learn and get better, but it's this capability to use multiple elements that makes this so strong. Then we can see geospace. We can see risk over on the right. There could be thousands of features that going in behind that, but this user at a level 1 or level 0 really just needs to know this is a problem, and it's highly accurate that this score of 95% of being risky is 95% most likely a problem. And I can see here quickly on the map that the risk plus the location shows me that perhaps things being done in the UK are not normal and are not, quite frankly, supposed to happen. Therefore, this is more likely to be fraud. But again, it's tying all of these elements together that make it so powerful. Then we can start to see sort of the deep link analytic. Now, again, this could be coming from machine learning heuristics. This could be combining it in the graph, as Graham is going to show us. But the point of this now is I can take it down a notch. I can go see the atomic level. Where is this going? What is the risk? What is the blast radius? Take that other data and then drill in even deeper. And that's really what these are designed to do. So now we talk about how those different users all touch that elephant in one place. So let's see a demo. And what I'll do is I'll jump over here. So now what we see in this case is perhaps I have a dashboard. Now this could be your Tableau dashboard, your Looker dashboard, whatever dashboard that you have today. Expero is not necessarily in the dashboard business, but what I'm doing now is I'm showing these panels or plugins. That's really what we're doing. We can directly connect those to the graph. We can directly connect those to the machine learning outputs, right? So that when those things are surfaced, I can see over here to the right that maybe I'm on the Azure network just as well as I could be on the GCP or AWS, but I can use some of those products to plug in here and say, well, maybe there's a password that I'm using for my single sign-on that's out of whack. Maybe there's a patch that there's a flaw that I'm using that I need to upgrade. But while that's happened, I notice that, look, there is this item of an alert. Now what I can do is I can look at that and back to that blast radius here, which is simply, maybe this is saying there's something coming in, an excessive host. Okay, well, maybe that's good. Or abnormal for now, but it's not horrific. But what I want to do now is I want to dig in a little deeper. I want to use the graph. I want to use the machine learning to start to do that. So thank you for finding this for me. But now what I want to do is look at this. And what I can simply do here is start to dig in on where this is going. Well, what I see now is there's a series of elements. Now, what I might want to do here is that is risky, and I see that and I acknowledge that, and I can see some data here. But what I want to know now is why is this URL and what is it doing? I want to go create a higher order of an alert that is perhaps more detailed. So what I'm doing now is I'm saying, okay, let's go create a new alert. Let's combine now this action of machine learning of a graph database and the other kinds of elements in one place. And what I want to do now is I want to say, okay, so when this host comes in, I want to combine it with a connection in a graph database that is with 10 degrees away of either known fraud or other problems that I have. So I can simply now build this combined block of logic where now I want to go run a Louvain connection. And if there is a connection within 40%, I want to now say, well, there is perhaps a community or a cluster of people that may be doing this in different ways, and they're hiding or obfuscating before they do things. So I've added now the power of that. Now, Graham's going to show us what that really means. Now I can attenuate that. So I can say, well, that entity, which is, do I trust this host? Well, no, not really. So I've got it all the way out here to say, what does that look like? Is it similar to other things I have seen previously from either attacks or vectors or other kinds of features? It's somewhere in the middle. And then are there communities and geography and page? Now, this can all change for your business or what your needs may be. But the point here now is this business person is controlling a very powerful capability here by attenuating what they want it to do. And you can see now that I can connect a business centrality, et cetera. Now, what I want to do is I actually want to go do this. And I want to say now what I want to do. Well, I'd like to schedule this in a real-time manner. I want to stop at number one, and I want to pop it to two separate persons' dashboards. So have them interact with it. Or I could set this up to immediately shut down the account and isolate perhaps a device or a server or something like that. But again, these are all parts of what we would work with our customers on to go do that. But the point now is I found the trigger. I'm creating an action. And then what I'd like to do now is actually go test it. So I can go run that. Now, when I save that, now when I get that alert over here in my dashboard, I've gone in much deeper. That alert has allowed me to see, well, the host had an email connected to an account that's directly connected to an employee. And then it looks like there are some anomalous elements that are going on inside of that system. And now what I've done is I've gone from what was a high level, and I can say, well, gee, I'd like to see Fran now, and I'd like to see why this is so out of whack. Well, guess what? It looks like he was indeed here in his time tracker and his HR system. He's out on PTO, but there was a number of failed logon attempts. And now it looks like there's a flurry of elements that have happened where they're trying to get access to these other systems. And what is it they're trying to do? We're not sure yet. But now what I've done is I've been able to make that link actually happen. So what I can do now is I can actually switch over and say, okay, great. I want to know how and what was going on at the server level. Now what I'm seeing is there were things that are way beyond what this person should have been doing. And I can see that there are files and IP addresses that are linked to other kinds of elements. What I've done now is I've stepped over the line. Now I'm seeing that there are processes that are happening. There are other kinds of files that are going on. And then by simply clicking in and using, again, the power of the graph, I can see that, well, there are sub files or sub things that I have seen before that are part of my heuristics. So what I've found now is this ability to do a deep link all the way from the sensing, all the way down to, this is actually a ransomware that looks like it's being copied and it's trying to reach back out to the web to make that connection. So what I've done now is in this sort of very quick vignette here is walk through kind of a day in the life. Now, again, each user may have a different view of this as we do that. So with that, I'm going to hand it over to Graham.
Thanks, Scott. I'm going to dive into the details here a bit about what's happening in the background, starting with some methods that you can use to do this type of analysis if you have a data science team in place, and then move on to showing you what happens actually in our product to showcase this stuff to users in the front end. So starting off here, I just wanted to mention that there are a huge number of both graph and machine learning techniques that can be used in the analysis of anomalous activity inside of a cyber network. And if you're interested to know more about these individual algorithms or how they're combined, jump over to the website. We have a bunch of blogs on that stuff. Okay, so let me show you a couple of them. We have 6 on this slide. They are not the only 6 that are used, but they are important. Just to pick one at random, you can look on the upper right-hand side at similarity and see that if we have graph structured information, we actually have access to behavioral information about what's going on inside of our users' network to be able to compare between patterns and not just entities. So an example of this is if we know that an IP address is or a device with a certain IP address is very similar to another device because of the same IP address, that doesn't necessarily tell us anything. It doesn't say we have a match. But if we know something about the behaviors that that device has conducted, as we do in this graph situation, we're able to much more accurately pinpoint what's going on inside of our network and potentially determine that there is some unusual or maybe fraudulent or attacking based activity going on. All right, let me step up a level and show you what the data model looks like, the data flow rather looks like here. So on the left-hand side, you see source data coming into our system and getting mapped through a series of steps into the domain of analytics, which is what I'm going to cover in this section. And if you're interested to know more about sort of data mapping or entity resolution or anything that goes on at the lower level, just reach out. My email's at the end of this presentation. Okay, so let's take a quick look at something on the left-hand side of this diagram, which is a high-level data model. So on the next slide, what we have here is the types of information that we feed into this graph system, this graph data model. And as Scott showed earlier, it doesn't all have to be in a graph database. We aggregate information from all over the place, any data source you might have, external, internal, or actually even analytics services that you have going on. Those can all be sources for this data model we're looking at. So it's everything you'd expect in your typical cyber analysis data model, clickstream data, information about device relationships and server logging, things like this. And then let's go forward one more slide. We can see a little bit more detailed look at this thing. Again, just cartoon level here, but just to give you a little bit more flavor. Of course, we have information about domains, specific IPs, server and host communications, and all sorts of things that are related to device and access, and then known user auth as well. And there are many, many more things that go into this data model. Happy to show those to you, but I just didn't want to put it all on the slide here. So go ahead and reach out if that's interesting. Okay, so now that we have seen a little bit about what's in the data model, what I would like to do is seek a bit forward here into the analytics space, and we'll talk about what happens in the actual background and how we make the determinations here about what potentially constitutes something that you would want to investigate further. So we look here at the behavioral analysis type of work, and this is a broad category of work with many algorithms. Again, check out those algos on the first slide. But what we're able to do using these behavioral identifiers, which I've just listed a few on the left-hand side, is we're actually able to typify some of the behaviors that we see in our historical data and map forward in time so that when we see those behaviors pop up again, we're able to then predict it and block it where that situation arises. And where might this be interesting, right? So stepping ahead one slide, what we'll see is potential attack, a potential bad behavior that we want to trace through attack vector tracing. So on the next slide, what we'll see is exactly that. We are tracing through the graph structured data set from input, right? That might be some sort of like malicious code injection, like I'm showing here. And then we can trace that out along the network that we have here modeled in our graph data structure, and all the way to the endpoints, and figure out what systems that attack has touched, or hopefully before that attack has touched anything, we can predict what the blast radius of that thing is, and we can prevent it. And that is what I'm showing here on the next slide. So as you see in this small graph, I've just sub-selected some data out of a bigger graph here. There's a PageRank score of that subgraph. And what we're showing here is, by the way, each node is an endpoint and the edges are actually the traffic between them. But what we're showing with this PageRank is the relative connectedness of other endpoints, which is important when you're trying to figure out where traffic is going to be communicated. And as you see here in this UI, we can then step forward and understand what's the impact going to be to our business. If we do know where those high communication centers are and what that potential blast radius is, we can then look in this UI and see what's going on before it happens, and understand what the resulting business effects might be and what data might be breached, for instance. All right, let's move forward to a structured threat detection example. So this is just another subset from a different graph database. And what we see here is a selection of potential servers that are potentially conducting fraudulent behavior or attack-based behavior, more generally anomalous behavior. So you see the word topology there, and what that means really is structure, geometry of this graph you see on the slide. By looking at the actual structure, just the geometry, like we can count things like the number of triangles and the amount of connectedness, like we just talked about. We can actually make determinations about what's going on inside of the behavioral context of our users, like whether those users are actual endpoints or whether they are bigger systems like servers, to get an idea of, again, what type of traffic are they transmitting and what type of behaviors are they conducting. So on the next slide, what I've done is I've taken a much larger example, a much bigger graph, what we see here on the left-hand side, and I've actually clustered it. And just like we saw in the smaller example on the previous side, although this is a little bit harder to visually delineate, is groups, colored groups of behavior characteristics on that right-hand side, which is the same graph. I've just clustered it. And why we care about this is yet another input into a graph machine learning algorithm that could predict and prevent attacks on your network. And that is, again, what I'm showing here in the rest of this section. So let's step forward one more slide and take a look at how this works. So we have an example here, and I've just copied over a slide, which I think was particularly interesting in its visual representation with users and traffic. And what we're showing on the right-hand side of the slide is something called a spectral decomposition. So that's super important. But all we can, the long story short is that we can actually encode what each one of these, let's say, endpoints or servers or any other type of device on the network, what they're doing using this type of what I would call an embedding strategy. And again, that is another input into our anomalous traffic prediction algorithm. So let's look at what one of those algorithms looks like at a high level. This is an actual top-level view of what a graph machine learning algorithm looks like. This is general. It could be any algorithm. But on the right-hand side there, number one, you see the clustered structured graph, which we looked at a few slides ago. And these algorithms tend to, most of them do anyway, extract a piece of that graph, which we might call an ego graph in the social network case, or we would call a device-centric graph in the cybersecurity space, and structure that information, that subgraph, into what data scientists call a feature vector. And that's important because that is the actual tangible object that feeds into the machine learning, any machine learning algorithm. And as we see on the bottom of the slide, we then run that algorithm, that graph ML algorithm, and pipe the results into the front end. And of course, it's stored back in the graph as well. And I have one more slide on this, which I'll show you next here, which is an actual implementation. So this is an output from a running TensorFlow graph machine learning model that shows on the left-hand side a graph, a subgraph like we just looked at, being input here into this machine learning. This is a neural network considering graph features. All that stuff in the middle is the actual neural network doing its thing. And on the output side, we have, unfortunately, I can't show the real data, but we have a cartoon there depicting what the risk activity is and the likelihood for anomalous traffic in this one user, in this one device in our network. Okay, so that was a lot of math and a lot of analytics and stuff. And it's super important to understand that. But if you were a level 1 or 2 analyst or whatever, as Scott was showing earlier in the demo, you don't want to have to care about that. And you don't. So this is our adaptive analytics module. This module shows outputs of potentially malevolent activity. And we just see a snapshot here of a screen where those nodes have been highlighted as red for potential investigation activity. We recommend that an analyst look into these things. And how would you come up with this? So let's step forward to the next slide. We can see a no-code configuration here, absolutely no-code configuration of a machine learning model, a graph machine learning model. So what we're doing here is we're actually generating all of those features I talked about early on, things like connectedness and things like PageRank and things like number of triangles. Those are the inputs to our network, our graph machine learning algorithm. Oh, and by the way, although I didn't show this on this screen because it's less interesting, you also would definitely include things like device IP, any type of advertising identifier, anything like that. Those features would also, this is where you would configure their injection into that graph machine learning algorithm. And as you see here, it's very simple to do this. You turn them on, you turn them off. If you choose to, you can configure them as I'm showing that little pop out with specific date ranges and specific attributes. And when that's done, and step forward one more slide, we can actually see the training runs that have come out of this. And the discerning reader here will see that there are some manual training runs and some auto training runs. Well, that is critically important, right? What happens here, as we all know, being practitioners in the business, is that attackers change their behavior all the time to try to evade our detection techniques. And so the other thing that this adaptive analytics module does is it automatically retrains those graph machine learning models for you based on situations in which it finds those behaviors have changed in order to be able to keep the system up to date and make accurate judgments about when a potential attack is happening and what the effects could be. So summing it all up here on one more visual slide from the Expero Connected product, this is another example of what the output might look like. So we started with one, and we'll end with one too here, where we have a view. In this case, we have a nice geospatial view accompanying this, maybe visualizing device traffic geospatially. Maybe it's information on the right-hand side about the connectedness of that information to other devices, other domains, and you can see that it is a temporal view as well. And these are the types of screens that a non-data scientist would actually use to be able to build their own models and detect anomalous traffic and attacks in real time and keep that system up to date. So let me summarize with one last slide. We talked about a bunch of stuff here during my section, and there are 4 salient points. So we need to have monitoring of our systems to know when attacks are going on. And we saw that we're injecting that information into a graph data structure, right? That connects, that's the connective tissue of all of our data. And it allows us to do these very sophisticated judgments and recommendations on those data sets. We have the actual implementation of the graph machine learning models. And you saw the front end of that just a few slides ago, where we have a fully recursive implementation that, that deploys those graph machine learning models automatically without any fancy coding or anything like that, just totally code free. We have active learning, which is that feedback loop that Scott talked about earlier, where the users are saying, yeah, that doesn't quite look right to me. The model understands that, the models understand that, the system picks it up and retrains those systems, that retrains those models, so the system gets smarter over time. And finally, we have those interpretability metrics. Those are the ones where we have the explanations about why the system is making those judgments, right? We think this is a potential attack vector because this device ID has a wildly different IP this second than it did last second, and it corresponds with an IP that we've seen an attack from before. So all of those things in summary, you can find those on the website, or just reach out to me. Again, my email's at the end of this presentation, and I look forward to chatting with you.
All right, thanks, Graham. Well, I think the takeaway here is that, we have the ability to help in any way we can. And that more importantly, how do we sort of, help you get there from here? And it could be any of the things you saw today. It could be just simply picking a graph database. And so with that, I think we can open it up for a few questions. Laura?
Yeah, thanks, guys. We did have a couple questions that came through. Let's see. Graham, there was one for you. How much data do I need to get started?
So we talked about a bunch of different data sets and data types. There is external data that you may be purchasing from a vendor. We can ingest that stuff. I'm sure, of course, you have internal data, and we talked about a couple of those different types. We can ingest that stuff. We should ingest that stuff. And I talked about a third and final data type, which is if you already have systems that are doing some of these judgments, we can actually ingest that information as well, so that the system considers all of those things holistically.
Okay, thank you so much, Graham. Scott, there was one for you. How would I get started?
It's a great question. So, it all starts with number one, your use case and some amount of data, as Graham just mentioned there, which is you can start with one sort of smaller system. You can start to test with some of these algorithms and test against a sort of control set of data. And so that's sort of step number one is use case, some amount of data, and it could be synthetic or obfuscated, but it's pretty easy to get started.
Cool. And then one last question here. Is this cloud-based or on-premise?
Again, so that is really up to you, the customer. We meet you where you're at. Some of our customers, when we do these, are as fast as 1 or 2 weeks. And so they may have something already set up in any of the 3 major clouds. So AWS, Azure, or GCP, and we're agnostic to that. The second part, then, if it's on premise, we can do that. Usually the onboarding or clearance to have OPSEC or DataSec will take much longer than the 1 week sort of POC. And then, if things go well, we can be in production in as fast as 8 to 12 weeks. So the good thing then is the cloud really is not the inhibitor. It really is more of your inside OPSEC or DataSec time frame to get it done. Sometimes clouds are a little stickier than on-premise. So that's kind of a long answer to, we can do either one.
Cool. Well, thank you guys so much. That was all the questions. Just as a reminder, we did record today's session. It'll be on our website probably by Monday, and then I'll be sending out an email with a copy of the recording. If you have any questions, feel free to reach out to Scott or Graham or info@experoinc.com or reply to the email. We'll be happy to set up a call and chat with you. Thanks everyone again for your time today, and we look forward to the next session.